Dilations and similarity in the coordinate plane. So we're kind of continuing on with this approach to dealing with similarity and proportion and looking at dilations. This is something you're fairly familiar with. To go back to the copier example, throw something on the copier, press enlarge or shrink, and what you're really doing is a dilation. So those are going to remain similar, and the dilation you have just this certain factor for it. So it's just a transformation that changes the size of the figure but not its shape. So the angles are preserved, but the size and the length of the sides would change. So you have a pre-image and an image are always similar. Again, you blow something up, both the small and the large are going to be they're going to be similar. So the scale factor describes how much the figure is enlarged or reduced. Scale factor of 2, you're going to double the size of something as far as the lengths of the sides, and that gets multiplied by both the x and the y coordinate if you are dealing with this on a point-by-point approach. So just to kind of walk you through what you might see in the book, finding the coordinates of similar triangles. If you know that these two triangles are similar, so triangle AOB is similar to triangle COD, and then it's just a matter of matching things up. So the length of this segment is 2, the length of this segment here is 4, the length of segment CO, and we have that OB is 3, so 2 is to 4, as 3 is to the length of OD, so you can find the length of OD, and really what that comes out to be, obviously it's 6, you can probably do that in your head pretty easily, so the length of OD is 6 units, that means we have a scale factor of 2. We went from 2 to 4 to go from AOB to COD. Now you will want to pay close attention to which comes first in the similarity statement, because that's how you want to list your scale factor so that matches up. That's really the only place you can get tripped up, I think, with these early examples. So if we have the triangle MON is similar to triangle POQ, and we start throwing in some coordinates here. So this is -15, 0, and M is -10, 0, and Q is 0, -30. So we have that -15 is to -10 as -30 is to what? So we work this out, and hopefully we'll get something that will work out. So we end up with 15x, -15x equals 300. So x has to be equal to 20, x being the length of segment ON. So if that length is 20 units, then, well, we could say that it's -20, which would give us the coordinate. So ON, so we have 0, -20, would give us the other coordinate. And then find the coordinates of n and the scale factor. So we have the coordinates of n, 0, -20, and this is MON to POQ. So -10 is to -15 as -20 is to -30, which all of this simplifies to the same number, which is just 2/3. So the scale factor in this case is 2/3. I think pretty straightforward. No real difficult math or anything like that involved with it. It's just a matter of keeping your pre-image and your image straight, which triangle is listed first in this case. So proving that triangles are similar in a coordinate plane. If we're trying to prove that triangle RST is similar to triangle RUV, we probably want to plot these points and sketch them out, make sure it appears similar, but then you have to prove it. You can't just say, yeah, they look like they're about the same. So you'd want to take the lengths of the sides and check and see if those are in fact proportional, because if the sides are proportional, and you can say that for all 3 sides, then that means that the triangles would have to be similar, because by the side proportionality theorem. So I don't think we need to go through the entire entire proof of this, but we can, do maybe just a quick sketch. So we have -2, 0 is the R, -3, 1 is S, and 0, 1 is T, and -5, 3 is U, and 4, 3 is V. So we have something that looks about like this. So we have some measurements we can throw in here, figure out the lengths of some of these figures. Let's cut to the chase so you don't have to see me up here doing arithmetic, but the distance from R to S is going to be the square root of 2, because we went from -2, 0 to -3, 1, so it's over 1 and up 1, which gives us a radical 2. The length of RU, which is from the -2 over to -5, so that's over 3 units and up 3 units. So we'd end up with 3 radical 2 for the length of that segment. And then we end up on the other side, we get R to T, so segment RT is equal to the square root of 5, because we're going over 2 and up 1. And then the length from R to V is going to be 3 radical 5. So that's just the distance formula 4 times to come up with those. And then what we want to be able to show is that, well, what we're hoping to see is that RS is to RU as RT is to RV. And when you put those over, you very nicely comes out that they are proportional, and the scale factor is 1 to 3, and we know that angle R is congruent to angle R. So by side angle side similarity, we have that they are in fact similar. So that should take care of that. So really that's all it is. We're doing the distance formula a couple of times, but other than that, there's really nothing particularly difficult. So it says, graph the image of triangle MNP after a dilation with a scale factor of 3. That means we're blowing it up to 3 times its current size. So we have these coordinates, and all we're doing is multiplying the x and y coordinate by 3. So for instance, M is -2, 1. So if that's -2, 1, we're multiplying it by 3, so it's going to become -6, 3. So that's going to give us our M prime. And N was 2, 2. So the point 2, 2, if it gets multiplied a scale factor of 3, that's going to be over 6 and up 6. So N prime will give us that. And then we have P, which is -1, -1. And a scale factor of 3 is going to give us -3, -3. And that gives us P prime. Again, I'm not going to go through all the arithmetic, but if we wanted to then demonstrate that these are, or to verify that these are in fact similar, all we do is find the length of Mn, compare it to the length of M prime, N prime, and do that same thing for each one of the sides, and then compare. And if we get that each of those ratios is equal to 3, then that means everything worked out quite nicely. And to verify, all we're doing is really checking our work. It's did we get the right points in the right spots. So that's it for dilations. Hope you enjoyed it and have fun, and hope you enjoyed the blizzard bag.